When an engineer plans a technology that doesn't yet exist in the world, that person might be called crazy. When you look at the history of Mercedes-Benz, some cars that came out of that factory were ahead of not just their own era, but 2, sometimes even 3 generations that followed. Now I'm going to tell you about 11 classic Mercedes that were a few years ahead of their time. You may have never heard of the items in this video before. Especially the last items will surprise you greatly. If you are a fan of retro cars or Mercedes-Benz, if you subscribe to the channel and turn on notifications, you can be informed about the videos I've prepared about classic Mercedes cars for you. If you're ready, let's begin. The first vehicle is the Mercedes-Benz W196, introduced in 1954. One of the most dominant cars in Formula One history. But what puts this car on the list is not its speed. Back then, all racing cars had open wheels. Many people did this because everyone was essentially copying each other. Mercedes, however, took to the track in 1954 with a completely enclosed, streamliner-bodied racing car. Not a form that cuts through the air, but one that passes through it. This innovation was the first concrete expression of the aerodynamic philosophy that today serves as the foundation for Le Mans prototypes, Formula E cars, and even modern sports cars' wind tunnel projects. When people saw it on the track at that time, they couldn't understand what they were looking at. They couldn't believe it was a racing car. It was like an image from the future. But this car was both of those things. Those who lost on the track that day had actually also lost the next decade. The reason is that Mercedes that day didn't just win a race, it presented a way of thinking. Juan Manuel Fangio won 2 world championships with this car, but as Fangio's name was mentioned for years, behind it was always that enclosed body, future-like car. History sometimes remembers not the machine, but the idea that machine carried. The second vehicle is the Mercedes-Benz 300 SLR, introduced in 1955. When talking about this car, it's necessary to clarify this first. The 300 SLR was one of the fastest racing cars of all time, but what also carried this car beyond its era was not its speed. It was this car's braking system that put it ahead of its time. Back then, cars didn't use disc brakes. They all used drum brakes because nothing else existed, or so they thought. The Mercedes 300 SLR used an air brake. There was a large panel at the rear of the car that could rise up. When the brakes were applied, this panel would rise, create air resistance, and slow the car down. An aerodynamic deceleration force in addition to mechanical brakes. Today, everyone probably knows the DRS system in Formula One. It works in reverse, but has the same principle. Changing the car's dynamics through the movement of an aerodynamic surface. The 300 SLR could do this in 1955. When the engineers of that time saw this system, they couldn't believe it at first. But then they took notes, and those notes came to life in other cars years later. Stirling Moss managed to complete the Mille Miglia in record time with this car. Nobody could break that record for years, because that car was not just fast, it also knew how to brake. And sometimes being able to brake can be much more important than accelerating. The third vehicle is the Mercedes-Benz W111 Fintail, produced in 1959. You might see this as an ordinary sedan, but when Mercedes introduced the W111 at that time, it offered something that existed in no production vehicle in the world: systematic crash safety engineering. An engineer named Bela Baregni had been thinking for years, if a crash is unavoidable, how do you get the driver and other people in the car out with the least damage? His answer would be revolutionary. The front and rear sections of the car were intentionally designed to crumple. Energy would be spent there, and the passenger cabin would remain rigid. The concept of the crumple zone exists in every car today and has become a legal requirement. It continues to save lives. But the day this concept was first brought to a car in the world was 1959, and that car was the Mercedes W111. That day, automotive engineering was divided into two eras, before the W111 and after the W111. Barigny had patented this idea as early as the beginning of the 1950s, but people weren't listening to him. Years later, that patent became the guarantee of many human lives. You've apparently passed through history without realizing it. Don't forget Bela Barigny's name. He is one of the most important engineers in the automotive world, and most people have never even heard his name. The fourth vehicle is the Mercedes-Benz 600 Grosser, introduced to the market in 1963. I mentioned this car in my video titled 11 Features that are only found in classic Mercedes. I recommend you watch that video after this one is over. Today we'll look at this car from a different angle. In 1963, the world's most advanced technology was in the space race. NASA was preparing for the Apollo program. Meanwhile, Mercedes used a hydraulic system in a passenger vehicle comparable to the space technology of that era. A central hydraulic network managed not just the windows, but the door locks, seat positions, sunroof, and even the rear seat dividers. Having such a complex system made the car's maintenance very difficult. The number of technicians in the world capable of performing this maintenance was not very large either. A hydraulic failure would ruin the entire system, which is why finding these cars in fully working condition today is virtually non-existent. But at that time, this complexity was considered not a weakness, but a demonstration of power. Today, the central control units in electric vehicles, the architecture that directs everything from a single nervous system. This is the digital version of that philosophy. Mercedes had done this analogically in 1963. The idea of central architecture is actually a descendant of the Grosser 600, only the materials have changed. The thinking has remained the same. The fifth vehicle is the Mercedes-Benz C111, introduced in 1970. Most people don't know this car. In my opinion, this car is one of the greatest losses in automotive history. Mercedes never put the C111 on sale. It was only a concept vehicle, but that experiment contained things the world had not yet seen. This car, which used a Wankel rotary engine, had gull-wing doors and a fiber-reinforced plastic body. It could go from 0 to 100 kilometers per hour in just 5 seconds. And all of this was in 1970. But the real revolution was not these things. The C111 was one of the first cars on which active aerodynamic tests were conducted. That is, while the car was moving, the aerodynamic surfaces changed, and pressure distribution was optimized according to driving conditions. The foundation of the active aerodynamic system that has become standard in high-end sports cars today was born in the laboratory of the C111 in 1970. This car was never sold, but it changed the world. A car that was never sold had become the fastest in the world. This car proves that you can enter history without ever being sold. The Mercedes C111 is the purest proof of that. The sixth vehicle is the Mercedes-Benz W116 from 1972 and the birth of ABS. Yes, the W116 was introduced to the market in 1972, but the ABS system was added to this car in 1978. In 1969, Mercedes and Bosch launched a joint project. The goal was simple, but the solution was incredibly difficult: preventing wheel lockup during braking. The reason was that at the time, a computer was nearly the size of a room. You needed a system that would calculate the wheel's rotational speed within milliseconds and adjust the brake pressure. Fitting this into a vehicle took 9 years. For 9 years, prototypes were built, tested, errors were found, and they went back to the drawing board. During this process, there were many who wanted to cancel the project. They said it was too expensive, too complex, and that nobody would like it. But Mercedes didn't stop. In 1978, ABS entered the W116 S-Class, and that day only one car in the world had it, the Mercedes W116 S-Class. Today, putting a vehicle on the market without ABS is illegal worldwide. Those 9 years of Mercedes and Bosch left a safety legacy worth trillions of dollars in history. That legacy began from beneath the brake pedal of a W116. The seventh vehicle is the Mercedes-Benz W123, introduced in 1978, and a new language in passive safety. Everyone remembers the W123 as a taxi car, that legendary car that covered millions of kilometers without breaking down. But the real legacy of the W123 was not its durability, it was its safety philosophy. In this car, the crumple zone concept that Bella Baregni had begun with the W111 was made much more systematic. The front and rear deformation zones were determined with precise engineering calculations. Door sills were redesigned to increase lateral impact resistance. The steering column, rather than moving toward the driver during a crash, collapsed downward. And all of this was done in 1978, at a time when modern crash tests were not yet a legal requirement. Mercedes was conducting its own tests, setting its own standards and exceeding them. The competitors of that era were not doing these tests because there was no obligation to. Mercedes, however, was doing it not because it had to, but because it was the right thing to do. This difference may seem small, but this difference is what turns a brand into a legend. We can still see the W123 on the roads today, not just because it's durable, because it was built correctly. The eighth vehicle is the Mercedes-Benz W126 S-Class from 1979 and the entry of aerodynamics into luxury. In 1979, someone buying a luxury car wasn't thinking about aerodynamics. They were thinking about power. They were thinking about leather. They were thinking about chrome. But when Mercedes designed the W126, it placed the wind tunnel at the center of luxury. At that time, the drag coefficient of a production sedan was generally between 0.45 and 0.50. The W126's value was 0.36. This figure was incredibly low for that era. It meant less fuel consumption, less wind noise, and more stable driving at higher speeds, but Mercedes had not compromised on luxury while designing this. On the contrary, it had designed aerodynamics as a part of luxury. Low aerodynamic drag meant a quieter cabin, and silence was the greatest luxury of that time. The W126 was also the first car to design the front and rear bumpers within the same aerodynamic integrity. The bumper was no longer just a protective piece, but an element that directed the flow of air. Today, every luxury automaker sees aerodynamics as a primary design criterion. But the day this priority was first applied, this systematically to a production sedan, was 1979, the day a W126 emerged from the wind tunnel. The ninth vehicle is the Mercedes-Benz W124, introduced to the market in 1984, and its integrated safety architecture. In the previous video, we had talked about the W124 due to its foam injection technique. But the truly revolutionary aspect of the W124 was not a single feature. It was the way it approached safety as a system. In this car, passive safety and active safety were designed together for the first time. Passive safety included crumple zones, a rigid passenger cell, and an energy-absorbing steering column. Active safety included ABS, improved suspension geometry, and weight distribution optimization. But what truly made the W124 revolutionary was that these two systems were interdependent. These systems were built to work together. Active safety tried to prevent the accident, while passive safety minimized damage if an accident occurred. And the transition between the two was a philosophy embedded into every component of the car. The tests conducted during the W124's production phase had never been done in any car up to that point. The pre-production test time was twice that of competitors. The reason was that Mercedes wanted not sufficiency, but perfection. The integrated safety understanding measured in today's Euro NCAP tests began to take shape in the W124's architecture. That car was not just a sedan, it was a safety manifesto. The 10th vehicle is the Mercedes-Benz W140 S-Class from 1991 and redefining the limits of technology. When this car was introduced to the market, most people criticized it. They said it was too big, too heavy, too complex. But they were wrong. The W140 was not excessive. It arrived early. This car had double-glazed side windows, meaning two separate layers of glass with an air gap between them. The W140 of that era had the insulation technology used today in broadcast studios, quiet rooms, and luxury offices. It had an automatic closing feature. That is, when you gently pushed the door, the mechanism would take over and close it perfectly. This 1991 vehicle had parking sensors. Lane-keeping system prototypes were tested in this car. And in addition to all of this, Mercedes integrated a driver information system into a car for the first time. The car had begun to talk to you about its own condition, engine temperature, oil level, brake wear. Many features that are standard in every car today came to life inside the W140 in 1991. But at the time, most people criticized them. History will remember it as a pioneer, because the only difference between excess and vision is time. The 11th and final vehicle is the Mercedes-Benz W210 E-Class, introduced in 1995 and the birth of ESP. In 1995 in Sweden, a journalist is testing the newly released A-Class. He performs a maneuver called the moose test, a sudden lane change. The car rolls over, cameras are recording, and this footage goes viral around the world. Mercedes is in the midst of a deep crisis, but within the crisis, a turning point occurs. The ESP system, Electronic Stability Program, was already in the development phase and was accelerated somewhat. And at the end of 1995, it was integrated as standard into the W210 E-Class. For the first time in the world, standard ESP was used in a production vehicle. When the car begins to skid, this system detects it before you do, applies brakes individually to separate wheels, and keeps the car in the direction you want. In a moment of crisis, the driver panics and turns the wheel, while the car calmly and calculatedly finds its balance. The system measures wheel speeds, steering angle, and lateral acceleration many times per second, calculates, and intervenes. Without the driver even being aware, the car was saving their life. Today, selling a car without ESP has been illegal in Europe since 2014 and in America since 2012. Every year, hundreds of thousands of lives are kept safe thanks to this system, and the first standard implementation of this system was in a W210. A technology born from a crisis became one of the world's most important safety systems. Sometimes history's greatest steps are taken in the most difficult moments, so these 11 Mercedes were not just the best of their own era. They were sending signals from the future. Each one asked questions that nobody had asked. Each one solved problems that nobody had managed to solve. And behind each one was the same belief. It may seem impossible now, but tomorrow it will become a standard. Many of the features in the car you ride in today were first implemented inside one of these 11 cars. When an engineer plans a technology that doesn't yet exist in the world, that person is no longer called crazy. That person is called a Mercedes engineer. In the next video, I'll talk about 11 classic Mercedes cars built to last forever. If you are a fan of classic cars or Mercedes, I produce videos about classic Mercedes cars for you on this channel. If you subscribe and turn on notifications, you can be informed about the next videos. In return for all this information, I kindly ask you to just like this video because that's how the algorithm works. See you.